Now we are going to deal with the optical fibers. It is module 3 and we go with the basics of optical fibers. What is an optical fiber? Optical fibers are long thin strands of very pure glass or plastic about diameter of a human hair. They are arranged in bundles called optical cables and are used to transmit light signals over long distances based on the principle of total internal reflection of light. Hundreds or thousands of these optical fibers are arranged in bundles in optical fibers. Now what exactly is an optical fiber? Optical means a light. Fiber, light carried by a fiber. So it is called as an optical fibers or fibers that carry light. In the form of, what is the principle involved here is total internal reflection. Now if you look at the figure over here, that is an optical fiber. One optical fiber, you can see a light is coming out, and here the light that is coming out from an optical fiber is highly directional. We have seen in the previous sessions the laser light is highly directional, less divergent, high focusability, high intensity, highly monochromatic source of light. So in an optical fiber, the light used is a laser light and the phenomena involved is a total internal reflection. So optical fiber, a fiber that carries light, laser light, and the phenomena involved is a total internal reflection. Now, before I deal with the total internal reflection, you should know what is a critical angle. Critical angle is the angle of incidence for which the angle of refraction is 90 degrees at the normal is called as a critical angle. So, what exactly is an angle of critical angle is the angle of incidence for which the angle of refraction is 90 degrees. So, the angle of incidence at which the refraction angle goes to 90 degrees, then the angle of incidence is called as a critical angle. Now, next is the total internal reflection. What is a total internal reflection? Total internal reflection is a phenomena in which a light traveling from a denser medium to a rarer medium for a particular angle of incidence which is greater than the critical angle for that pair of medium will be reflected back in the same denser medium. This phenomena in which light reflects back into the same denser medium without losing any energy is called as a total internal reflection. Now in the next slide, I am going to explain you what exactly and how exactly the total internal reflection is happening. Now if you look at the figure over here, you can see three rays A, B and C are the three rays having different angles of incidence. Now if you look at it here in the figure, it has been mentioned as N1 is greater than N2. That means the value of refractive index of a N1 is greater than the refractive index of N2. What is a denser medium and what is a rarer medium? A denser medium is a medium in which N1 is greater than, that is called as a denser medium. Then what is a rarer medium? For example, I can tell you air is a rarer medium and glass is a denser medium. How we can judge what is a denser and what is a rarer medium is, if the refractive index of air is 1, refractive index of air is 1 and for a glass it is 1.5 depending upon the type of a glass. Now let us assume refractive index of air is 1 and refractive index of glass is 1.5. Now in this, air becomes rarer medium because refractive index is less, and glass which is having refractive index of 1.5 becomes a denser medium. So refractive index determines which is a denser medium, which is a rarer medium. If you consider two mediums, if one is having a greater than the other, the one which is having a higher refractive index becomes a denser medium and the one which is having a lower refractive index becomes a rarer medium. Now in this case, we are seeing the total internal reflection is happening only when a ray passes from a denser medium to a rarer medium. Now if you look at it here, we have mentioned clearly as N1 is greater than N2. That means a ray is passing from a denser medium to a rarer medium. When a ray of light travels from a denser to a rarer medium, it bends away from the normal. This is sign conventions which we all know about it. It is bending away from the normal. As the angle of incidence increases in the denser medium, the angle of refraction also increases. So if you look at the figure here, the ray A from N1 it is coming to N2. That means it is passing from a denser medium to a rarer medium. theta 1 is the angle of incidence and theta 2 is the angle of refraction. If you look at this, theta 1 becomes angle of incidence and theta 2 becomes angle of refraction. Now what does the second point says? As the angle of incidence increases in the denser medium, the angle of refraction also increases. Now we see that. Now consider another ray B, which is bolded there, with a ray B for which the angle of incidence is increased. That means theta C is the angle of incidence for B, ray B. Now when you increase the angle of incidence here, if you see B dash is the refracted ray. Now if you increase the angle of incidence theta C, what is happening to angle of refraction B dash? If you see, it becomes 90 degrees. We have seen earlier what is the critical angle is the angle for which the angle of refraction, the angle of incidence for which the angle of refraction is 90 degrees. So this theta C becomes a critical angle because angle of refraction, that means OB dash, at that place the angle of refraction is 90 degrees. Now, if the angle of incidence is greater than the critical angle, the light ray is reflected back in the same medium. Now, we take another ray C, which is having angle of incidence greater than the theta C. Now, what is happening? See the totally internally reflected ray you can see as C dash. Now, what is the condition for this is, as discussed earlier, total internal reflection is happening only when a ray passes from a denser medium to a rarer medium and the angle of incidence is greater than the critical angle, then the ray is reflected back in the same medium. So here C is the incident ray and C dash is the reflected ray because it is total internally reflected because the angle of incidence is greater than the critical angle. So it is not entering into another medium, it is reflecting back in the same medium, that is N1, which is nothing but a denser medium. So this phenomena is called as a total internal reflection. Now what is an optical fiber? Here optical fiber is a transparent dielectric material like glass or plastic which carry light along it based on the principle of total internal reflection, which we have discussed here. Now if you see the figure here, it is an optical fiber. The internal part is called as a core. Surrounding the core is nothing but a cladding, and surrounding the cladding to give a protective jacket, polyethylene jacket has been given to protect the optical fiber. So optical fiber consists of a cylindrical transparent dielectric material of high refractive index called core. Here the inner part is called as a core. The core is having a higher refractive index. It is surrounded by another dielectric transparent material of low refractive index called as a cladding. Next, surrounding cladding in turn is surrounded by a cylindrical insulator called sheath, which gives a mechanical strength and protect the fiber from absorption and scattering. So this is the structure of a optical fiber. It consists of a core, cladding and a jacket. Next, what is a propagation mechanism in an optical fiber? When a light is made to incident at one end of the core for a particular angle of incidence theta naught, the light ray will undergo total internal reflection at the boundary of the core and the cladding, which is possible here when N1 is greater than N2, where N1 is the refractive index of the core and N2 is the refractive index of the cladding. This is a propagating mechanism in an optical fiber. Now we will see how exactly it is happening in the figure. If you see, it is an optical fiber. The inner part is called as a core having a higher refractive index, and the outer part covering the core is nothing but a cladding which is having a lesser refractive index when compared to the core. Then what is happening here is inside the core, it is inside the cable, the core is having a higher refractive index. So it is a denser medium and the cladding becomes a rarer medium. And when the ray of light is being incident onto a core, what will happen is total internal reflection will take place. Where exactly total internal reflection is taking place here is at the interface of core and cladding. If you can see there here, at the core and cladding interface is a point where core and cladding distinct. You can make a line here, that is a distinction. So at the core and cladding interface there is a total internal reflection. When does total internal reflection we can see here is when the angle of incidence is greater than the critical angle, then the ray is totally reflected back in the same medium. Now here core is acting like a denser medium, cladding is acting like a rarer medium. So first condition is satisfied. So second condition, when the angle of incidence is greater than the critical angle, when the ray of light is entering into the core with a particular angle which is greater than the critical angle, then that ray is totally reflected back in the same medium, thereby total internal reflection takes place. And like that, multiple total internal reflections takes place, and finally the ray of light is coming out of the optical fiber. This is the propagation mechanism in an optical fiber. Thank you.